Alrighty, well, welcome to Tim Time Projects, and on this episode, what will we be doing? Oh, we're going to be checking the voltages on the HQ-129X. This is kind of like going to be an uncut version. I mean, I will remove the stuff that's just me dawdling around, which is most of the stuff. But turn it on. We already have the negative in place. We're going to use the Simpson 260 today, and I have it set on positive DC voltage here. I know it's a little bit hard to see because we're going to be working on this vacuum tube right here. So let's see the move it down a little bit. I can see this. There we go. Here it is here. I have it on the 50 volt scale. We're going with positive volts DC. Black's plugged into the common and the red's plugged into the plus because we're not going with any crazy voltages. So I believe I have all the preliminary stuff set to what the manual says. And first thing we should come upon is about 3.2 volts. So we're going to turn that to 10 volts. And on the 10 volt scale, which should be DC, it'll be the bottom one. So it should be right around in this area here. And that's going to be on pin 5 of V1. So V1's right there. I'm going to light this up a little bit so that I can see what I'm doing. And I have you zoomed out as far as it can go, so you're not going to get any more than that. So there's 1, 2, 3, 4, and pin 5. So why am I showing on a 10 volt scale? I'm showing 7 or so volts. What are they saying? I should have. Let me look at that again. Pin 5, they're saying 3.2. Let's look at pin 6. Should be 102 volts. So we're going to need a 250 volt scale on that one. Pin 6. 4, 5, and pin 6. We are on the 250 scale right there, so we're looking at about a little over, about 105. That seems about right. Pin 8 should be 196. So we'll leave it on the 250. Pin 8 is back over here. And we're seeing about, gee willikers, we're seeing about 230. So we write these voltages down. So that's V1. What do we say? 230 for pin 8. We didn't do 7. That's going to be an AC voltage. Pin 6 was 102. We had about 105. And pin 5, we're supposed to have about 3.2. Pin 5, 4 and 5. So we're on the 10 volt scale. We're seeing about 7.5 volts. All right, let's look at, real quick, we'll go and look for the AC voltage on pin 7. So we're going to turn this guy to AC, and we'll look at pin 7. Why am I not getting on? There we go. We're getting about 6 volts. Oh, we'll say 6.25 volts. 6.25. And what were we saying we should get? 6.2. So we're getting that's correct. I don't really think I need to check those all because those are all going to be the filament voltages. And If the radio's working, we know the tube's working, or the filament's working, because otherwise the tube wouldn't be coming on. All right, so let's move to V2. We have to check pin 3 of V2. We're going to go back to DC. And let's see. V2 is a 6K8 tube. And it is going to be pin 3. Should be 210 volts. We'll pop that back to 250 again. We're going to pin 3. Where's the slot? There's 8, 1, 2, and pin 3. So we're almost pegged out at about 200 and there's 25, so 235. 235. Let's see, pin 3. So they're saying 210. All right, let's look at the next little guy. Where are we going from there? Pin 4. Pin 4 should be about 91. So just short of 100. V2, pin 2, 3, and 4. Now, we're just short of 100 on the 250 scale. We'll go with that. So we'll say about 95. Pin 4. 1, 2, 3, 4. 95. Pin 6. What should 6 be? 98. So about the same thing. Pin 6. 5. Pin 6 is this guy right here. Yep, about the same thing. So we'll give that a check. 98. We'll say somewhere in that area. We're not going to worry about pin 2 or pin 6 because that's the heater element for the tube. So we'll go right down to pin 8. Should be 3.2. Pin 8. Right here. And that's a little bit on the low side. It's about 2.8. And let me make sure it's scaling. On the 10, we're right about 3 actually on the 10 volt scale. So we'll go 3 volts on that. All right. Moving right along. I'll put this back up on the 250. We'll make it a little bit quicker while we do these. Let's see. Pin 3. I'm sorry. Yeah, pin 3 of V3. So there's 1, 2, and here goes 3. So we need a lower reading. Pin 3. We're on the 10 volt scale. We're about 9.5 almost. 9.5. Does that sound right? V3. By the way, these are DC voltages I'm checking here. So we're on pin 3, V3. It's saying 6.3, we got 9.5. 4-0, pin 5 should be 6.3. V3, 1, 2, 3, 4, 8, 7, 6, and of course 5 is behind everything. Well, 5 just a tie-in spot. 1, 2, 3, 4, Yeah, 5 ties into the same thing as 3, so on the 10 volt scale, we're seeing about 9.25 again. I mean, there's literally a wire going from one to the other. I don't know how you would have less. All right. Pin 6 is going to be a little bit higher. We'll go back to 250. 3, pin 6, 7. Here's 6 right here. We're on 250. We're showing approximately 105. 105. Let's go pin 7. We don't worry about. Pin 8. V3, pin 8. Wow. Alrighty, about 240. Pin 8 is 240. Let's see how off we are on these. That's the third one. Pin, they're saying 206. Now, just for laughs, I'm going to pull this meter down. All right, and you can look over here. So you're seeing both of them. And I'll turn this on. What are we looking? Pin 8. We'll have to put on the 500 volt scale. Because pin 8 should be around 206 volts of V3. We were getting 240. So let's see. Put that on 500. Let's find us a 500 scale. Be right here. The 5. We should see right around the 200 mark right here. So let's look at this. Guess not excitement for the camera. We're on DC volts plus, the 500 volt scale, and that would be where it says 5. So we're going to look right where the 2 is. So that should be right around there where my finger's pointing. Let's see what happens when we look at that. And we're at pin 8 of V3. Pin 8. So here it is saying about 240. It's about the same thing we got. Okay. So our voltages are pretty accurate between the two of them. I'll leave it like this so you can watch if I get electrocuted. Okay, so we're going now to V4, which is right here. V4, we want pin 3. There's pin 1, 2, and this should be 3 right here. Let me see if it's labeled. Yep, that's 3. So we got to come down a little bit in the scale. There's the 10 volt scale. Pin 3 is showing me a little over 8 volts. So we'll say 8 point, we'll just say 8 volts. 3 is 8 volts. 5 is going to be 3, 4. We want 4, 3, 4, and here's 5 right here. 5 on the same setting. We're at almost exactly 9 volts. All right. Pin 6, it's probably going to be a little higher, so we'll put it at 250. U4, there's 3, 4, 5, here's pin 6. Pin 6 on the 250 scale is approximately 105. That's about what we got for the other one, 105. Not worried about 7. Pin 8 is going to be high in the 250. U4, pin 8 would be right, this guy right here. Yeah, about 240. Move on to V5, which is going to be this guy right here. V5, what do we need from you? Pin 3. It's another 6 SS7, by the way, so that's probably going to be pretty low. V5, pin 3. 1, 2, and 3. On the 10 volt scale, we're about 4 something. 4.2, we'll say. How's that? 4.2. And I'll throw my pencil. 4.2. Pin 5 should be another somewhat low. 1, 2, 3, 4, and here's 5 right here. 5 right here. Come on. It's actually the same one as this. It should be about the same thing, 4.2. Pin 6 is going to be higher. Pin 6 is about 125, almost 135. So say 135, pin 6. Not worried about 7, and pin 8 should be really high again. 5, pin 8. 215. 5, 10, 215. 215. Let's just look and see what they're saying for that. That's V5. 1, 2, 3, 4, 5. Should have 3.5 volts. We had 4.2. Should have had 3.5. We had 4.2. Should have had 97. We had 135. We didn't check that. Should have had 193. We had 215. So I wonder if it might be a good time to just shoot right over to the regulator tube or the rectifier tube and see what it's got. Well, the BFO's that one. It can't be 11. The 5U4 should be this one right here. Oh no, that's the regulator. The 5U4 is over on that side, underneath everything. Doesn't it figure? U4, pin 1, 2, 3, 4. Let's see if I get in there to pin 1. Let me make sure which ones are going to be the AC. 5U4. 5U4 is going to be pin 1. Should be 212. DC. U4. Looks like that would be this pin right here. we're showing 240. 240. IV4 is 240. Pin 2. And there goes my pencil again. Oh, that hurts. Pin 2's above. Let's see. Pin 2 on the 500 scale is about 300, and that'd be 350, 310, 320. 320. 320. Four. All right. Looks like pin 3 is should be the same because it's just where it's tied together. 1, 2. One, 2. Here's 3. Yep. So we're at 500. So that's between 4 and 6, but it's the 500 scale, so it's a little bit higher. About 240 again. 240. 240 or 340? We're on the what, 500 scale, so that was 240. Is that correct? Pin 1, 2, 3. $240 if we're on the 500 scale, which we are. Let's see if that might be right. Okay, there's pin 4. We're on the 500 volt scale, so we're reading almost exactly 300, just under 300 volts AC. Oh, AC, we actually have to come to this scale. So we're reading right about 300 volts exactly. Yes, we're going to say right about 300 volts on pin 4. Then we have to do the same thing with pin 6. That was 4, 5, there's 6 here. Same thing. Let's see what 7 and 8 are. Come on. Now you 4, 7, and 8 are 108. And they should be DC. Yeah. So back to DC. Down to 250. Eight is about 240. I'm sorry, that was not that. No, that was 7 is 240. 8's almost 300. Let's look at that. 8 is almost 300. On the 500 volt scale. So we're about 320. Okay. All right, I guess what I should start to do here is I really should know what my line voltage is, so I'll check that first. So I'm over here on the Simpson. I have it on AC 250. We're expecting to see it around 120, so that line right there would be 125. That's DC, so be 150. So right in that area. Let's see what we get. I'll put one there and one on the meter on the switch. All right. Looks like we have 10, 20, 30, 40. We have 120, well, 125. Almost the exact center of the scale. So our AC voltage is 125, just for reference. I did find something too, is I had the sensitivity, I had bumped it and I didn't have it all the way. I don't know if that's going to make any difference, so let's just look at vacuum tube 3, or let's see, vacuum tube 3, pin 3. Is that the one we want? No. Vacuum tube, we'll go with the first one. 1. So pin 5 of vacuum tube 1 should have been 3.2. We had 7.5. So let's put this back on DC and go to 10. We wanted V1 pin 5. 1, 2, 3, 4, and that would be this guy, right? Yep, right there. Yeah, so that would definitely account for that. So what are we getting on the 10 volt scale, DC? Well, now I'm not even getting 2 volts. So I think we're going to have to take a look at the, that's a voltage divider circuit in there. So let me make sure they said sensitivities at max. I'll put them a 2.5 volt scale. 2.5 volts. We're getting 1 volt. But we can look at this. When I change this sensitivity, how radically it changes. I'm just bumping it. I went from 10 to about 9.75. So we're going to write that off to be that. Let's. All right, here I'm going to spare you the pain of watching. Basically, I'm just checking all the voltages, more of the same you've seen. If anything good comes up, I'll show you. So in case you didn't get it, the main reason for the discrepancies in the voltages was because this sensitivity circuit there that's in the it's along the whole RF-IF chain, and I had inadvertently bumped it, and then I also found out that there was a wrong resistor in there, so that pretty much cuts that. And then my line voltage was about 10 volts higher than when it was originally spec'd out, so that made me feel a lot more comfortable with all those voltages. Okay, here I'm working, checking the voltages. I had pretty off the wall voltages from the BFO amplifier, the 6SJ7, and I decided that I needed a CAT scan. Kitty cat, you can't be up here. That's really dangerous. Not while this is on. No voltage. Let's go to ohms. Yeah, that's what I feared. 100 ohms. How did that happen? Actually, let me get this out of here. Oh, remember I've been saying I've been having weird issues with the BFO. There, you're back. Okay. So let's see. 100K, that's what they're calling for. I'll check two different schematics to be sure. I don't think it was 100 ohm. That would be just insane. Let's look at this schematic, and it is also saying 100K. Maybe I was on drugs when I did that. I don't know. Let's see. Let's turn that off. Well, we'll leave that on. We might want that. Okay, so the problem here is on that 6SJ7 tube, the one on the right-hand side of the screen there, you'll see the resistors going up, and there's two 100K resistors. One supplies the B plus to the plate, and the other is one of the, I think it's grid number 2 bias. Well, I must have inadvertently put 100 ohm resistors in there, so I had to replace those. Now that I have the right resistors in there, I think we might see something a little more in line with what we were looking for. Maybe. Okay, now I'll turn it on and hope for not smoke. Turn it off, turn that on, turn that back to that. That seems different. Now when I turn it on BFO, it actually gets louder. Okay, so let's check our voltages again. At pin 4, we were hoping for a negative 2.3 and we had 20. DC minus. Pin 4. One, two, three, and 4. On the 50 scale, we're showing, I don't know, 12, 14. We'll go 13. Minus 13. All right, I believe this has gone on long enough. I mean, if you've stayed with me this long. But here we have, these are the voltages that I see, and just about everything is explainable as I showed before with either the sensitivity adjustment or the 5U4 or the line voltage to the 5U4. The only one that I still have any question about is grid number 1 on the 6SJ7 tube. I'm getting about a minus 13 and it's calling for like about a minus 3. However, the BFO still works great. So I'll have to research further into that, but I'm going to press on anyhow. I should probably add here too that the bottom chart is derived right from the manual, and the top for the 129 HQ-129X and the top chart are my actual measurements. Okay, well, upon close examination of the sensitivity circuit, this resistor right here, and the schematic call out to be 100 ohms, and there's a 10 ohm resistor in there. So I'm going to take that and swap that out with a 100 ohm resistor. And not a very big change, but as you can see, the little bits of change really affected what my voltage readings were. So I'll take care of that. And I'm not expecting big things from it, but we'll put it back to what it should be. Looks like a really, I don't know, a lot of these resistors look like they're pretty factory, so I'm not sure why that would be. But anyhow, let's press on and get that done. All right, sorry to drag this on for so long, but I just kept finding more and more things to fix. So we're going to wrap this episode up, and then we'll move on, and the next will be the doing the actual alignment. So if you stayed with it, thanks for watching. I guess you made it this far. Take care and give it a thumbs up if you liked it. See ya.